All right, so we're going to continue on from the last section, doing exercise, completing some double reactions. So bear in mind, a reiteration of what we just went through. The double reactions, just like single reactions, they have rules that you need to follow to know if they work or not. All right, so if they're going to work, they need to produce one of three things. One of three things being a solid, insoluble thing, a gas, or a liquid in the form of water. Now, water can either look like H2O or HOH. Both of those are the same thing. So you're looking for those to see if the actual double reaction works. So let's look at the exercise in the yellow pages and see if we can figure it out. Again, they're giving us the word problem, and we have to figure out the products, balance it, figure out if the products are solid, liquid, gas, aqueous, everything. And then after we get all that done, we figure out is it going to work or not. Okay, so let's look at this first one. We've got sodium carbonate and copper 2 chloride. Let's figure out what the product is going to be. Again, what you're going to do is you're going to take the positive metals and you're going to switch them. Okay, so I'm going to stick with this being my first one. So instead of being sodium carbonate, I'm going to see sodium chloride and copper carbonate. Now I'm also going to look to see the charges. Sodium's a +1, chlorine's a -1. Yay, no charges have to be added on there. Copper 2 chloride or a copper 2, we know there's a +2 charge to it. Carbonate is a -2, -2 +2, yay, they're good. So I don't have to put those down. But I do need to balance now that I've got that all figured out. Ooh, one thing I missed. I got to figure out, is it a solid, liquid, gas, aqueous? So sodium chloride, if I look to my table E or F, can't think right at the moment which one is which, but you're going to look to that table and you're going to find out, is it soluble, aqueous, or insoluble, solid? Because chlorides, except for a couple exclusions, are aqueous. We leave it as aqueous. And the carbonates, I believe the copper 2 chloride is, carbonates are insoluble or solid unless it's a group 1 or ammonia, and copper is not one of those, so it is a solid. Okay, let's balance this puppy. We've got 2 sodiums here, 1 sodium here, so let's fix it. Let's put a 2 there. All right, we got 2 chlorines, yay! 1 copper here, 1 copper there, 1 carbonate, 1 carbonate. We are golden. Now, does it work? Will it occur? Will the reaction occur? Ignore my cat. All right, so aqueous, solid. Solid's one of the things that needs to happen for a reaction to occur. So yes, it works. Yay! Let's look at this next one. We've got hydrochloric acid and strontium hydroxide. All right, we're going to switch the metals or the positive cations in this case. So hydrogen is going to replace strontium, and I'm going to get HOH, and then I'm going to get strontium chloride. Now you're going to be like, hey, Miss Co, you put a liquid down. You didn't put aqueous. Remember what I told you about HOH? HOH is H2O. There's 2 hydrogens, but I wanted to keep the OH together, just like we would normally see it as a hydroxide, because if you look right here, there are 2 of them right here, and I don't want my brain to go insane trying to like break everything up, so I'm leaving it as is so it makes it easier on my brain. Okay, so let's look at this. All right. Oh, and strontium chloride, again, the halides or chlorine are soluble or aqueous, barring a couple things, and strontium is not one of them. So it is aqueous. All right, let's balance this puppy. So hydrogen, hydrogen, yay. Chlorine, chlorine, yay. Strontium, strontium, yay. Hydroxide, 2. Ooh, hydroxide, only 1. So I got to put a 2 in front of here just to balance that out. And you're like, Miss Co, that's so weird. I promise it will work out. It will make your brain so much happier instead of counting everything up. All right, so I added 2 in front of that, but if I do that to this hydrogen, I got to go over here and put 2 here. If I do that here, I got to put 2 over here with the chlorine. And if I do that here, 2 strontiums. Oh, hold on. I did something funny. 2 of those, 2 of those. I think I might have messed up right here. Strontium. Yep. There should be a 2 right there. I do apologize. There should be a 2 right here. That means there should be no 2 here, which evens everything out. This 2 actually needs to go over here. Sorry. That's my bad. But does this work? Well, let's think back. Double reactions need the solid, the gas, or water. There's your water. Okay, so let's look at this next one. We've got lithium nitrate and sodium sulfate. Switch the sodium and the lithium. I like to keep the lithium first because it just I like to go in order. So lithium sulfate and then sodium nitrate. Yay. Let's see if I need to balance anything. And I don't think in my brain I balanced anything on this. So we're going to go with it and hope that I didn't screw this up too bad. Balancing it out. I don't know why I put a 2 here. Shouldn't go there. There should be no 2 here yet. So I'd need a 2 here. I need a 2. Yeah, this is going to be very weirdly done. The balance is off on this. So do pardon my balancing. My balancing won't work on this because I messed up and didn't balance over here when I did the remaining part. So double check yours. Make sure the lithium is -1. Strontium is, sulfate is -1, which it is not. If you look over here, that'd be a 2. So there should be lithium 2 right here. And yeah, so if there was a 2 here, that'd be fine. Or sorry, there'd be 1 there. I wouldn't have to. My stuff is off. All right, but let's look at the prediction. Is the reaction going to occur? So sulfates are soluble. I believe all soluble except for a couple exclusions. Lithium isn't one of them. And then you have your nitrates, and all nitrates are soluble. So they're both aqueous. If you don't get a solid, a gas, or water, it is going to be aqueous. It won't be a double reaction. Nothing will occur. Nothing will happen. So no, that won't happen. And I do apologize about my, pardon me, my balancing. My balancing did not work out this time. I'm so sorry. All right. So the last one, we had the synthesis. Remember, that was one thing plus one thing combined together to make one huge thing. And then decomp was taking that one huge thing, breaking it into 2. Single replacement, an element in a compound gives you the element out of the compound and a new compound. Double replacement, compound, switch up the metals to give you 2 different compounds. All right, so the last one is oxidation, the fun one to balance. And you'll notice there is a fraction right here. Guess what? I don't do fractions. So we're going to the whole number. So basically, you would times everything by 2 just to even it out. Here's the deal. If you do something to this side, the product side, or the reactant side, whatever you do to the reactant side, even if it's just 1, you have to do it to everything else. Just like in math, what you do to one side, you have to do to the other. All right, so combustion reactions. These are reactions with oxygen. The reaction of hydrogen with oxygen, in this case, gives you water. Ignition temps is 580 to 590 degrees Celsius. Explosive. The word explosive. When stuff gets big really, really fast. The rapid release of energy into the surrounding area causes the air to expand quickly. All right, so reactions with oxygen. To complete a combustion of hydrocarbons, and that's more of an organic term, so don't worry too much about that right now, yields carbon dioxide and water. So any form of CH plus O2 will give you CO2 and H2O. It could be a C12H100 plus O2. It doesn't matter how many is over on the reactant side, it will always equal CO2 and H2O. But balancing will not be fun. All right, so let's look at this. We got to balance it out. C4H8 plus O2 gives you CO2, H2O. So first I'm going to balance out my carbons. So there's 4 here. I'm going to put 4 here. Okay. Now I got to balance out the hydrogens. There's 8 here, 2 here, so I want 4 here. Now let's see about the oxygens. There's 4. 4 and 2 is 8. Plus 4 is 12. I need 12, so I need to balance out those oxygens. Putting a 6 there, and we're all good. So looking at this, octane, an oxygen in an engine gives you carbon dioxide and water, right? But octane is C8H18. And obviously you got to balance this out. Which again, start with the carbons. So I would put an 8 right here. And then 18. So if there's 8 here, 18, I'd put a 9 here. So that's 8 and 2, 16, and 9 is 25. I don't like that. I'm going to multiply everything by 2 just to make my life easier. So there's going to be 18 here. There's going to be 16 here. 16 and 2 is 36. 36 and 18 is, sorry, mental math right now. I think it's like 50. So 60, it might be 66. So there's probably going to be 33 oxygens. Like I said, start with the carbon, do the hydrogen, last but not least, do the oxygen. Remembering this times the O2 right here plus this by itself. Do not switch that up. Don't think, oh, because there's 16 here and you add a 5 here, things will get better. Make sure you're counting out all the oxygens as you go. All right, so combustion is also fuel and heat of the human body. Be careful of if oxygen is present in the compound being burned. So look at this, there's an oxygen here too. So you're going to look at this side. When you go to do this, you got C6H12O6 and O2. So there's 8 on this side. All right, let's balance the C. 6, so I'd put a 6 here. 12, I put a 6 here. 6 and 2 is 12. Sorry, if I put a 6 here, 6 and 12 is 18. There's 8 right here. So if I take 18 minus 6, I have 12, so I'd only put a 6 here because I'm subtracting the 6, okay? All right, so table I, a new table. So this one, the first 6 reactions are combustion. And we'll get into this a little bit later, just to let you know. But it shows the enthalpy. Again, we're going to get into that later. But it shows the 6 reactions. And look, if you were to be given this in any test, any quiz, anything, and you needed to balance it out, it's balanced for you. So if you see any combustion reaction, make sure that you are looking right here for the combustion reaction to see if it's all balanced for you. So you don't even have to think. You're like, let me go to table I to double check, see if it's there. And if it's there, I mean, bonus for you, you don't have to think too much. You just have to write it down. All right, homework. Finish up the travelogue, 2. Balancing and classifying part 2 and 3 in the worksheet, and the word equations. I know it's a lot of green pages. Just work through them. You already did the hard part in the worksheet for balancing and classifying from equation 1. All you have to do, you got to classify it, and you got to, I think, add the phases to it. Okay, if you have any questions, please don't hesitate to ask, and I hope you guys have a great day.